Hello guys, I just wanted to take a quick look at how I work with my particle fluids and how I rasterize them and what sort of post-processing I do in cups, because I got some questions regarding that process. So let's take a look at that. To start off, we just have a particle fluid simulation here. This is based on the SPH solver I wrote a blog about, but it works with anything. We also have just pop fluids here. So yeah, just some fluids in the 2D, aligned for the cup space, so -1 to 1. And we then bring them into cups, where we find our first custom node. And this is a custom rasterizer. It's based on the rasterizer by Hallam Roberts, which I think is based on the rasterizer by Lewis Saunders. Take a look at those for reference, and this is what this is based on. So this uses atomic adds to rasterize the particles, but the special thing is I added a radius attribute, and it also can use p-scales. So if we set it to this has p-scale attributes, and take a look at this. We can see our points being rasterized. We can turn the p-scale on and off. So if we turn it off, the points all have the same size, and if we turn it on, it uses the p-scale attribute. And then we have a general multiplier up here. And we also have this fall off slider, which gives the particles a nice fall off around the edges. That way it's a bit smoother. And that's basically it. As you can see, this is additive. Since we're using atomic adds, each particle gets added on top, which causes the image to be really bright. As we can see here, we have values of 8 and 2 and 5. That means we need to remap afterwards to just bring us back to normal usable values. I just used the remap node set to extend, and then you can play around with the ramp here and your input max. This was mainly used for Houdini 21, but with Houdini 22 we have the new rasterize G-splats node, which can take care of that for you. It's not additive, so the values are mostly normalized, I think. So you can also use this, but I'll include this in the file anyways, since it can be a bit faster. And yeah, you have like a little more control with the fall off and the p-scale values here, the settings. The main workhorse of this effect is this node right here. I called it Dispersion distort. This has 3 inputs, one for our color. Then we need a UV map and a ramp. This works very similar to the stock distort node, where we plug in our layer we want to distort and then a UV map. For the UV map, I just converted the layer to black and white and calculated the slope. And the node then just distorts your image along this slope. And functionally, this node does the same, but as it distorts the image, it also samples a ramp, so this can be any ramp. And if you plug in this normal gradient, what is it called? The infrared gradient, you will get this nice dispersion effect. And that's basically all there is to it. This has the same settings, like you have dispersion scale, which can go negative. And then you have a samples slider, which controls how often the ramp is sampled, which is similar to the pixels per step slider here. And yeah, you can use any ramp to get different effects here. Most of the time you'll probably want to keep it this, since this is the classic dispersion color ramp. but you can also use any UV map. So for example, I rasterized the velocities here as well, and I just increase them a bit, and we can plug that in there as well. And then you get these nice swirls. Yeah, I think there's a ton of use cases for this. I use it a lot just because it creates nice dispersions, which are always nice to look at. You can also just use a random fractal noise here to disperse anything, to disperse whatever you want. Yeah, that's basically it. I'm gonna probably upload this file to the SPH files on Gumroad. My tip is just create a recipe from this. That way you can always access it regardless of what Houdini version you have. Yeah, that's basically it. Let me know if you create anything cool with this, and thanks for watching.